So continuation of electrostatic. Electrostatic means when charges are at rest, we call that electrostatics, and the electric field, the region around the charge where its force can be felt, we call that as electric field. It's always out from positive and it is into negative. So if two like charges as they repel, so between them there are no field lines in this region, as you can see. That shows that there is no force between the charges. Then material can be classified as conductor or insulator. Conductor means the material which allow the charge to flow through them. As we know, the metals, they have a lattice of a positive ion and the delocalized electrons. So through this lattice of the positive ion, the electrons can actually move, or electrons can actually flow. So as these electrons can move or these electrons can flow, or they allow the electrons to flow from one place or one end to another, then we're not moving in a straight line randomly, they're moving, but they can flow out from one end to another, so we call that as a conductor. But if there are some materials, they don't have spaces in them or no free charges or particles, so they don't allow the electrons to flow through them. So as a material which does not allow the electrons to go through them, only electrons can be there at the surface, but it cannot pass. There is no way. So we call them as insulator. So in terms of electrical conductivity, material can be insulator or material can be a conductor. Conductor which allow the charges to flow through it, such as all the metals are conductor, and insulator, the material which are not allowing the charges or electric charges to flow through them, such as plastic, rubber, wood, or glass. Then what are the dangers of static electricity? You have seen many times when there's a thunderstorm, then there's always associated with a lightning or a flash. So what is the reason for this? Because there's a friction. As in a storm we have a cloudy weather, and these clouds, they get, or there's a friction between the air as these clouds are moving. So as these clouds are moving, there's a friction between air and the cloud, and due to the friction, the air, one side it loses, like cloud example, it lose electron and air gain that electron, air particles, so there will be a net positive and negative charges on them. So as a result of too many positive and negative charges, this buildup of the charges, what it cause? It cause induction on the earth surface. Like example, this is our earth. So this negative charge, what it will do? It will induce positive charge on the earth surface. And if there are buildings or trees, so top of the tree will also get positive, or top of the building, a tall building is there, that will also get a positive. So as a result, what happened? Because this tree or the tall building, they are very close to the negative charge, so these negative charges start to move toward them, and when these negative charges are moving, as the result, what we see a flash or the lightning. So this lightning occur due to buildup of the charges, and that is mainly due to electrostatic friction. So as you can see here, the due to the friction, the cloud and the air get charged. Air is negatively charged, cloud is positive, and this negative charge induce positive charge on the earth surface. But likely, like tall buildings, these negative charges, as they move, they produce a flash or a light, and likely they will strike or hit a tall surface, because they can easily be induced, or electric charges can easily be induced on them as they're closer to it. So as you can see, like example, all these four different, like 1, 2, 3, 4, 5, 6 different surfaces are there. So which surface likely the lightning will strike? 1, 2, 3, 4, 5 and 6. So which surface likely they will strike? It will strike surface 2. Why? Because that is closer to this air, the charge air, That's why the lightning or the flash easily strike this surface. Is it clear the concept of the lightning? Anyone having a doubt or a question till this point? That why there is a lightning or a flash and why it is likely to hit the objects which are tall. So the friction between the air and the cloud get the air charge, and this charge here, the air particles, the electrons, when they move, as a result it produces a flash or the lightning, and likely it will strike the tall buildings or trees, or even. So these are some images for the lightning or the flash. Basically, we are not able to see the electrons. Electrons are very small, but as a result, what happened when these electrons are moving? When these electrons are moving, they're emitting out energy, and that energy we can see in the form of light. So this, the random movement is there. They're not moving in a specific direction, but as a result, when they hit, they will hit the surface. Sometime you find the lightning does not strike, like example, it end up before striking the earth. What is the reason for that? Because when the charges are moving, they're losing their energy. So if the charges lose all of their energy, so the lightning or the flash will not strike the earth surface. If they have enough energy, then the lightning or the flash will strike the earth surface. Is it clear? Any doubt till this point? So these are some more images about the lightning or the flash. Basically, the friction between the air and the cloud that charge the air, and this air, when it is charged, it start to move. The charged particles start to move, and as a result, what we see a flash or lightning strike the different substance, different earth surface or different objects on the earth. Then there's also another danger of this electrostatic charging is in refueling. What happened, like example, this is normally for aircraft, airplanes. When these airplanes are flying at a very high speed, like example, this is the airplane. So when it is flying at a very high speed, as a result, what happened? There is a friction between the air and the aircraft body or airplane body. As a result, what happened? The aircraft body also get charged. So there will be a charge, either positive or negative. For example, air get a positive charge and aircraft body is getting a negative charge. But then for refueling, as this plane land, and because already the body of the plane is completely charged. So if this body is completely charged and if they directly start to refuel or add a fuel to this, so what will happen as a result? Because already it is a charged body, if they try to add a fuel to it, this, whenever the charges move, the movement of the charges might produce a spark, and that spark is sufficient to burn this fuel, and it can cause an explosion. So to avoid this, what they do, they first remove the charge. Before refueling, they connect an earthing wire. So when they connect an earthing wire from the body of this aircraft, the charges are removed, and once the charges are removed, as it is neutral, so once it is neutral, now they do refueling so that it won't produce any spark during a charging, and it will be safe to refuel a aircraft. So this can happen for oil tankers as well, this can happen for aircraft as well. So when oil tankers are refueling, the oil tanker and refueling pipe may be charged up due to friction, and that might build up, that is charged due to friction, and that might build up of charge, might produce a spark, and that spark is sufficient that the fuel might catch a fire. So the dangers of static electricity, one is the lightning or a flash, and the other one is refueling. To overcome this, we use a lightning conductor. Very tall buildings, what they do, they use these lightning conductors. What is the advantage? These lightning conductors are made up of metal. So what happens when the air gets charged? So electrostatic induction, the nearby, this will be positively charged. So when the lightning strike, this is made up of metal. So metal will take their charges, and we call them as a lightning conductor. So because metal can easily be charged, or metal are good conductor, so likely when there is a buildup of the charge, like example negative charges build up, so which point likely they will strike? They will not likely to strike a building, they are likely to strike this metal rod, or we can also say lightning conductor. Once they strike this lightning conductor, the charges strike this lightning conductor, these charges will go out, and it will be safe even if it is a lightning or a flash in a thunderstorm, because likely this will pass through a metal conductor, as metals are good conductor, or a lightning conductor, as compared to a lightning or a flash strike the building. So it reduces the chance that a lightning strike the building simply to strike the lightning conductor. So using of use of the lightning conductor that make it safe. So the concept, like we connecting the conductor to a charge object, as we already discussed, we can remove the charge, or charge can be added to this. So this is about electrostatic. Now we'll discuss few questions related to this. So some questions related to electrostatic. The first one, what is electric field? So when we talk about electric field, the definition, a region around a wire carrying current, which a compass needle can experience force. No, not a compass needle can not experience electric force. It is magnetic. A region in which electric charges experience force, that is true. A region where the electric charges experience gravitational force, wrong. And region through which electromagnetic radiation pass, that is called, that's does not call, that's known as a medium, but that's not known as the electric field. Electric field is a region where the electric charges can experience force. Like example, we have a positive charge and we place another positive charge, so like charges repel, so this positive charge will move away from the large positive. So this whole region around it, what we call this region, we call that as electric field. So region where the electric charges can experience force, we call that as electric field. In question 2, a negatively charged rod held close to one side of a metal sphere and the other side of the sphere is earth. Which diagram shows a distribution of metal charges in the metal? If we bring a negative charge, so positive will be here one side and negative will be on the other side. But because earthing is connected, so if earthing is connected, the electrons should go out. So A cannot be an answer, because in A, what happened? Electrons are negative charges are still there. Again, B cannot be an answer because negative charges are still there. What about C? C, even though positive charges are there, but because there is a negative charge rod, so positive charge should not be evenly distributed. They should be more towards the negative charge. So means these positive charges should be more towards the negative charge. And what about D? D is the correct, because as electrons will go out, majority of them are positive, and due to the charge rod, they are attracted towards the other side. So D is the right answer for this. Then student rub a plastic rod with a cloth. The rod become positively charged. Why a rod? Like example, there is a plastic rod and student rub with a cloth. So this one is a rod and here is a cloth. When we rub them together, as a result, what happened? The rod become positive. So why the rod become positive? Because it means it is losing electrons. When substance lose electron, that will get a positive charge, and the substance gain electron will become negative. So protons, they, as I mentioned, any option loss or gain of proton is totally wrong, because proton cannot be loss or gain from the atom as they are present inside the nucleus. So it's difficult. So either it can be gain electron. If it gain electron, then it should be negative. But it lost electron, so it will be positive. That's why C is the right answer for this. And which quantity is measured in coulomb? So what is the unit for coulomb for? Coulomb is used to measure the charge of an object. If we want to measure charge, we use coulombs. Then in question 5, there's a polythene rod and the cloth. The rod become positively charged and the cloth become negatively charged. So we have to show which which give to the charged particle and the direction, because the rod become positively charged. It means rod is losing electrons. So it cannot be C or D are totally wrong. So either it will be A or B. So the charged particles are electrons, and which direction they will move, because the rod is positive charge, so they should travel from rod to the cloth. So that's why B is the right answer. Then there is a current in the metal wire. Current is always due to the flow of what? Flow of electrons. So which particle move? Electrons are moving. Electric current is refers to movement of electron. So when electron move, we call that as electric current. And the diagram represent two different electric fields. As you can see, the strength of electric field is a distance between the two electric field lines. If they are closer, it is stronger, and if they are away from each other, so it is weaker. So field 1 is stronger and field 2 is weaker. Stronger electric field, it means there will be a large force, and weaker electric field, it means there will be a smaller force. Then which direction the electron will move? As we know, if we place, so which row gives the shows the direction of the force on electron. So if we have electron always move in opposite to direction of electric field. So electrons will move downward. Both fields, as they're pointing up, the electron will move down. And what is the, in which one the electron will experience a stronger force? So direction of the force on electron or direction of the movement of electron is always opposite to the electric field. And which one it will experience a stronger force? That is in field 1, because the field lines are closer. So it will be larger force is there in field 1, and the direction of the movement of electron is A. As we already discussed, that electron move always opposite to direction of electric field. Then these are the structure questions. Figure 8.1 shows a metal sphere standing on insulating base where R is negatively charged. Name a particle S move when R is brought closer. So this is a metal sphere. When you have a metal sphere, a metal contain a lattice of a positive ion. So there is a regular arrangement of the positive ion and the delocalized electrons. So electrons are there in the metal which are free to move. But as a result, what happens when we bring a negative charge rod? So like charges repel and unlike charges attract. So these electrons, instead of distributed evenly, they shifted more towards the right hand side. So majority of them negative charges on the right hand side and majority of the positive charges on the left hand side. So name the particle in as that move towards when R is brought. So which particle will move? Always electrons will move. And we have to add to a diagram positive and negative. So we don't have to draw this lattice, we just have to draw positive and negative. Keep one thing in mind, because overall metal is neutral. So if you are making 4 positive on or 4 negative on the right, then there will be 4 positive on the left hand side. So distribution should be even. Then describe the action which now need to take place so that S become positively charged. So now what we want to do, we want to make it completely positively charged. So how I can make this completely positive charge? So first we bring a charge rod. So one side is positive, the other side is negative. I want to make it permanently positive charge. So I should connect an earthing wire. When we connect an earthing wire, what is the effect of this earthing wire? The earthing wire will allow these electrons to go out, the negative charge or electrons to go out. When these negative charges will go out, majority of them are positive now. So as the majority of them are positive, then what we should do, because we don't want these electrons to return, so we should remove the earthing wire first, and then we should remove the charge rod. So when we remove the earthing wire and charge rod, how these positive charges will appear now? So they will be distributed uniformly on the metal. So you have to write this in your own words, like describe what 3 marks, what we should do to make it positively charged. So what we'll do, we'll connect an earthing wire which allow electrons to move out from metal sphere and make them or create a net positive. So connect earthing wire which allow the electrons to move out from metal sphere. It will produce net positive charge on metal sphere. And then what will happen, as it will produce a net positive charge on the metal sphere. At the last, first remove the earthing wire first. After that, remove the charge rod. So this is how we make the object permanently charged, as we already discussed this part earlier in the session. So another question is there. Figure 8.1 shows a high voltage supply. Explain what is meant by electric field. So what is the definition of electric field? Electric field, it is a region around the charge. The standard definition is, it is region around the charge where positive charges can experience force. This is the standard definition. The region around the charge where the positive charge can experience force, we call that region as electric field. Even negative can experience force as well, but just to make a direction of electric field, it is the standard definition. region around the charge where the positive charges can experience force, a region around the charge where other charges can experience force, and it is always from positive to negative. Then figure, draw electric field lines. So how to draw the electric field lines? One side we have positive, the other side we have negative. So the field lines are always out from positive and into negative. This is how the electric field line. But for parallel plate, you should be a unit, like there's a constant electric field between the plates, so we should draw equally spaced lines between the metal plates. Then, as you can see in this figure, there's a charge. Conductor A is given a positive charge. On the figure, mark sign of the charge induced at X. So what will be the charge at X? Positive or negative? What will be the charge here induced at X? So it will be negative, and what will, so opposite positive charge will be their other side. But keep one thing in mind, if you make 4 negative, then there should be 4 positive. Explain how these charges are induced, like why these charges are produced, why one side is positive and other side is negative, and instead of 3 marks. So you will mention like charges repel, unlike charges attract. So the positive or conductor A which is positively charged attract the electrons from conductor B. So because these electrons are attracted, so this causes electrons to shift or to electrons to move to from one end to another. So majority of electrons are here, so that's why negative charge, and few electrons are on the right hand side, so net positive charge. Explain why the charges X and Y are equal in magnitude, means why they have the equal value. Because metals are neutral, originally metals are neutral, they contain equal number of positive and negative charges. So because a metal is neutral and it contains equal number of positive and negative charges, that's why the charge which is produced at X is same as charge produced at Y. B is now connected to earthing. So now if we connect B to earthing, what will happen to charge at X and what will happen to charge at Y? That is a question. Like when we connect, when we bring a positive charge out, majority negative will be here and positive will be here. And now we connected earthing wire. It can be connected anywhere, it won't make difference to the effect. So whenever we connect an earthing wire, so this positive charge rod this time will attract the electrons from the earthing. So as a result, what happens? These electrons will enter, and when these electrons enter, so what will be the charge at X? The charge at X will remain negative. But what happened to charge at Y? The charge at Y will also become, or you can say it will become neutral. You can mention, because like if there are 4 positive, then there will be 4 negative, or electrons will enter. So 4 positive and 4 negative, so they cancel out the effect of each other. So you can say the charge at Y become neutral as the electrons are attracted, and charge at X will be remain negative. So we have to mention here, so charge at X, it will be same, no change. and charge at y, what happened? It is neutralized by electrons which move from earthing to sphere or conductor B, because it is not a sphere, so that's why we say it's conductor B. So this was about the electrostatics. Any question or a doubt related to this topic? As we started the concept of electrostatic, discuss about how we can charge an object, why the object is charged. So I'll end this session and share this recording with you.